Okay, so we're talking about the rules for cosine today. The rules for cosine look a little bit different, but we have two of them just like we do for sine. We have one for the sum, cosine of alpha plus beta, and we have one for the difference, cosine of alpha minus beta. Just like the rules for sine, they're going to look identical except for the operation in between the two terms. One will be plus, one will be minus. Yeah. For cosine, the two terms are cos alpha times cos beta and sine alpha times sine beta. And it's going to be those same two terms in the other rule. Only thing that's going to change is the operation between them. And this is why we're doing cos second. Cos is a little weird. Cos, the operation is going to be opposite what it is inside the trig function. So if here it is addition, here it becomes subtraction. If it starts as subtraction, outside it becomes addition. So cosine, the operation flips. And for those of you who do not have a great memory for things that are mathematical, do not panic. I don't expect you're going to remember that. Yeah, you're going to have an equation sheet for your test. You just have to know how to use it, yeah? Okay, so we are going to apply the rule to our first example. It says find the exact value of 5 pi over 4 minus pi over 6. 5 pi over 4 minus pi over 6. Yeah. I see those fractions on our unit circle. I see 5 pi over 4 right here. I see pi over 6 right here. That makes me happy. Now I just need to split those two angles into separate statements. Yeah. So, cosine of angle 1, 5 pi over 4, minus angle 2, pi over 6. And I know the rule is cos, cos, sine, sine. And the operation between them is opposite what's in parentheses. So cos 5 pi over 4 times cos pi over 6. It started life as subtraction, so this is plus sine of 5 pi over 4, sine of pi over 6. And a reminder, that's the only new part of the math, right? Is that splitting up of the angles and using the sum or difference formula to separate them out. From here, it's pulling values from the unit circle. Yeah? Who can tell me what cosine of 5 pi over 4 is? You should have your unit circle in front of you. What is cosine of 5 pi? Yeah, I heard it in a couple places. Negative square root of 2 over 2. Perfect. Times, because we're pulling off the x-coordinates, right? Cosine is the x-coordinates. I need the x-coordinate for pi over 6. Is root 3 over 2, yeah. Good. And then plus. And then the signs are the y-coordinates. The y-coordinate at 5 pi over 4 is negative root 2 over 2. Good. And the y-coordinate at pi over 6 is 1/2. Perfect. And we're starting to see a pattern form. What's my denominator going to be? 4. Because unless I am on an axis, all of my fractions are over 2. So my denominators are either going to be 1, 2, or 4. Those are my choices. 1 times 1, 2 times 1, or 2 times 2. Yeah, I only have 3 possible denominators. So I know this is a fraction over 4. First pair of fractions, negative root 2 times root 3 is negative root 6. Good. Second fraction, negative root 2 times 1, negative root 2. Happy face. Perfect. Yeah. Same process as for sine, just that sum or difference formula is different. Yeah? But once you've got it set up, the plug-in step is the same. Pull the values from the unit circle, shove them into the sine or cosine function. Yeah? Okay. One more. I'm going to do it faster this time, and then I'm going to have you do the third one in your small group. Yes, Anthony? As soon as Alexis gets back. I promise. I heard the ding. Okay, so let's erase the color coding so we can use the picture again. We have 2 angles. We have 3 pi over 2, which is here. We have pi over 3, which is here. Yeah. So I know ultimately that's where I'm pulling my values from. It's a cos, so I know that my split is going to be cos, cos, sine, sine. Cos 3 pi over 2, cos pi over 3. And then is this going to be plus or minus? Minus. Yeah, this guy switches. Cosine switches. Started as plus. When we split it up, it becomes minus. Good. And then sine of those same angles. Sine of 3 pi over 2. Sine pi over 3. Okay, give you a minute to write. Give you a minute to think. And then I'm going to start calling on some people to help me fill those values in. So if you don't have a unit circle out, grab it out now. You're going to help me. It's been a long day. I need some help filling this in. Everybody's found their unit circles? All right, we're going to start with Jennifer's table. Somebody at Jennifer's table, what is cosine of 3 pi over 2? 0. I agree. Very good. X coordinate is 0. Excellent. There we go. Nicholas, what is cosine of pi over 3? 1 over 2. Very good. We need the x coordinate. 1/2. Perfect. And we have a minus. Next, LD. What is sine of 3 pi over 2? Perfect. -1. That's the y coordinate down here. Excellent. And then the last one, Omar, what is sine of pi over 3? Square root 3 over 2. Excellent. Perfect. And this looks slightly prettier than the last one. 0 times a half is what? 0. We know that guy goes away. Heck yeah. I see a negative next to a negative. Means my answer is going to be positive. And 1 times anything is itself. So I'm pretty sure that we're just left with root 3 over 2. Yeah. So there's mechanics here, right? We identify the two angles. We split them up using the appropriate sum or difference formula. And then we pull the values from the unit circle to substitute in. Yeah, so same steps over and over again. I'm going to put a couple minutes on the clock. I want you to try example 3 in your small groups. So example 3 is find the exact value of cosine pi over 3 minus pi over 4. Daniel, by the time Anthony gets back, class is going to be over because we've got less than 10 minutes left. Is it an emergency or can you hold it? Okay. It's a short day. You guys are almost free. All right, do I have a volunteer who wants to come do it on the board? Somebody feeling brave or very proud of what they did? Sad face. Chickens. I have an anxiety disorder. I'm up here all day. You guys could do this. I need someone to boss me around then. Who can tell me what to do? Sounds like Aureli's bossy. Aureli, tell me what to do. Okay.
So I got cosine pi over 3 times cosine pi over 4 plus sine pi over 3 times sine pi over 4.
Do we agree with Aureli so far? I see some nodding. Very good. What do we do next?
Then, I guess we refer to the unit circle, and from there I got 1/2 times square root 2 over 2 plus square root 3 over 2 times square root 2 over 2.
So far, so good?
And then 1 times 2 square root equals square root 2 plus square root 3 times 2 equals square root 6 and over 4.
As two separate fractions or as a single fraction, because the denominator is the same. Yeah. I agree. Yay. Very good. Perfect. All right, so tomorrow we're going to use those skills to start looking at tangent and what we can do for sums and differences inside of tangents and co-functions. Fun times. You should have enough information to start the delta math. I would encourage you to do that so you're not trying to do it all on Monday afternoon. Yes, Melissa? No. Two separate fractions is equally correct. Yeah. What you're seeing, Melissa, is that I am a lazy mathematician.